Hello everyone, I'm Zewen. Today, my partner Zhang and I are going to introduce our project that the price of Airbnb in New York City in 2019 and analyze what the price will be related to. First of all, as you can see, we import the package to be used and we import our data from Kango, which this is information of the data set, which shows there are 16 variables and 48,895 rows. And you can see some variables don't get that high values, which means it probably exists the non-values. So let's check it. We from this result we know that name, host name, last review, and review per month have non-values since those values, including host ID, is not useful for us to predict, so we decide to drop them. Also, we want to explore more variables. The neighborhood group, we can know that there are 5 groups in this variable. Manhattan has the most houses, and Staten Island has the least. From the room type, there are 3 different room types. And we can know that the entire home or apartment is the most popular room types. We make the scatter plot of price and room type. Actually, we have thought to use box plot of these 2 variables, but since the price range is too large, the box plot is not too well. So we use scatter plot. We could see that shared room has the lowest price. However, when we make the box plot of room type and availability 365, these 2 variables, we can know that the hosts who are willing to share their room could allow more dates for booking. And this scatter plot is to see price distribution in different neighborhood groups. We could see the price of Brooklyn and Manhattan are generally on the high side. Relatively, their price range are wider. We could see the price of Bonix is lower than the other group. And this box plot is to see the number of days when listing is available for booking in different group. From Brooklyn to Staten Island is increasing trend in their mean. From the plot, we can know that the average dates for booking in Brooklyn and Manhattan is pretty small. And the house in Staten Island group has highest average dates for booking. Also, we know that the price in Bonix is pretty small range. The surprise thing is that the dates for booking has large rank. So we predict that the hosts are more willing to rent their house in Bonix into Airbnb to let the customer to book. Next, my partner Zhang will introduce the rest part.
Next, we begin to explore whether the number of days allowed for booking is related to the price. From the scatter plots below, we find that due to the large number of different prices, the distribution in the interval from 0 to 365 days is different to identify. Next, we decided to analyze the distribution of prices. As can be seen from the following figure, most of the prices are actually distributed in the range of from 0 to 500 or 500, which to the distribution of prices is skewed to right, and this can be founded from the skew score is 19.12, very large and not ideal. So we try to use the natural logarithm of prices, square roots, or use the Box-Cox method to get a better skew score, which means making the price to become a relatively normal distribution. By comparing the scores, we decided to use the method of taking the natural logarithm of the price to replace the price itself. So next, we want to explore the relationship between all other variables with price. So we processed the original data, such as re-encoding the categorical variables so that they will be added into the correlation calculation. And we also converted price into price log. From the figure below, we can see that the price log has indeed become a normal distribution. Next, we created a heat map about the correlation among all variables. As we can see from the figure, both longitude and the room type are highly correlated with the price. And next, Wendy will introduce the rest parts to us.
We decide to count the number of different level of prices and want to see the distribution of each level of prices. As you can see, we set the different price level, and the price between 100 and 200 has the highest number of houses. And we also make the histogram of price level and fill with different neighborhood group. We could note that the price of Airbnb of Brooklyn are mainly between 50 and 100. And Manhattan are mainly between 100 and 200. Queens, Staten Island, and Bronx are also mainly between 50 and 100. We also make some box plot between different price level in neighborhood group. And we could note that the houses are more willing to set their price range into 50, between 50 to 200. Since these two box plot have no outliers, and those five group present normal distribution. Also, we make the map of neighborhood group to clearly see the distribution of different level price of Airbnb. The color of the map indicates the price level, and the darker the color, the higher the price. And you can see the small sign, the different sign means different group. And when the price range is less than 100, there are large number of distributions like these two map. You can see that there are many spots on the map, but with the price increasingly increased, the distribution of the house is becoming small. But we still could see that in Manhattan and Brooklyn, those two areas, there are very large distributions. So next, my partner Zhang will introduce the last part.
As Wendy found above, the price data is more concentrated in the range from 50 to 400, so we plan to only use the data in this interval. Next, in order to take categorical variables into our models, we re-encoded the data and then divided the encoded data set into two data sets called trend and vol. And then we try to fit a linear model. Here we use the score function to judge the quality of the model. We listened to Nick's suggestion and found that the accuracy score of the linear model is R square score. The score shows that the model does not seem to be particularly good. So we also evaluated the RMSE score of the model, and the results are still not particularly satisfactory. For this model, we checked the QQ plot for the first 200 data. It is found that many points are not on the line, but the points are still roughly evenly distributed on both sides of this straight line, and the trend is basically the same as the line. Then for the first 50 data of the test dataset, we put the predicted value and the actual values together to check the accuracy of the model. It can be seen from the figure that most of the predicted values are more conservative than the actual values. We considered that the variables with the same meaning may bring noises, so we removed the several variables that we thought may have the repeat meaning. For example, for the variables which are represent location, we just use longitude and latitude. In the end, the refitted model we got does not seem as good as the original one. And then considering the correlation metrics we got, we plan to keep only two variables, longitude and room type. So we remove all other variables, and the result of the model has become worse. Next, we try to use two special linear regression model called rich and not so in turn, but the results are not still were still not ideal enough, and even become worse than the original one. We consider that the price may be more nonlinear, so we try to use random forest model or the single decision tree model. Firstly, we stratified the price and then fitted it. Then we still got bad results to overfitted models. Finally, we try to get the best one among, we try to use the gradient boosting regression, and then we got the best one among all the models we got above. That's all, thank you.